In this video, I'm going to talk about topic 8.9, the volume of a disk method revolving around the x or the y-axis. Our essential question is, how do you calculate the volume of a disk? And our I can statement is, I can calculate volumes of revolution using definite integrals and the disk method. So in this video in particular, we're just going to go through this first page together, which is kind of an introduction. There's no examples on it. So the disk method is if we're using areas of the known cross sections from the previous two topics, is not the only way calculus and the definite integral can be used to find the volumes of three-dimensional solids. The solids in this topic and the next will focus on those with cross sections that are all circular. So yesterday we talked about cross sections that were triangular or rectangular or half a circle, a semicircle, or even a square. And the solid grew out of the base that was the top minus bottom part. So we can actually have a solid grow out of a rectangle that we revolve around an axis. And you can see that it makes a disk. Let me show you that a little bit better visually. So if I have that rectangle, I can take it and I can rotate it around an axis. This time it's rotating around this axis right here. And we're rotating it all the way around and it makes a disc. It should, in theory, this particular applet doesn't make it look solid, but you have to envision the fact that this is actually solid. All right, so a two-dimensional figure, which is rotated about the x-axis, becomes a three-dimensional figure. So that's what they're talking about here. We're taking this little rectangle, we're rotating around that axis. So we're going to develop the formula for that. So recall that the formula for the volume of a cylinder is V equals pi r squared times h. This is just the area of a circle times whatever the height is between the top base and the bottom base of the circle. A disk is basically a very short cylinder where the height h is actually the W value. So they're talking about it's the width value. The radius retains its actual meaning. The pi pops out in front and you get the following formula below. So to find the volume of the solid of revolution with the disk method, and we can't apparently figure out how to spell disk. It could be spelled either way. Use one of the following. So what they're telling us to do here is that we've got the pi, which was from the pi r squared. Okay. This is going to be, our function is going to be the radius. So that's going to be the function. And then we're going to square it. And then in order to add all of these little things up, so we're going to have a bunch of these little disks in here. So in a whole bunch of them, that's where we do integration. So we're going to integrate that, that value. And then this part here is representing the width or the height in the formula from the volume of a cylinder. And it doesn't matter whether you're going in the x direction or the y direction. It's the same idea. You just switch from dx's to dy's.